Hey there, this is Mr. Alexander, and this video is for Algebra 2 students, Starting Point High School, and I'm going to go over a couple of things we did in class on September the 16th and September the 17th. The two things we did in class were we were finding, graphing inverses, and also proving that two functions are inverses. So I just want to show you a couple of things here. At the bottom of this page, it says graph each function, its inverse, their line of symmetry, label the function and its inverse on each graph, then give the domain and range of the function and its inverse. So I think the easiest place to start is that line of symmetry. You might remember from class that the line of symmetry is just the line y equals x, and I like to draw that with a dotted line like that. That's the line y equals x. Don't forget to label it. And if I want to graph this function, it's a parabola, it's quadratic, and it's x minus 2 squared plus 3. Now you might remember from the last unit what this minus 2 and that plus 3 mean. Quadratic, the parent function starts at the origin. It starts at this point 0, 0, but this thing has been shifted right 2 and up 3. So I'm going to regraph this parabola, and I'm going to shift it to the right 1, 2, and up 3. So that parabola actually starts right there. And that's at the point 2, 3. Now to get some other points, I'm just going to plug in like 1 and 3 for x into this equation. So to get these points, 1 minus 2 is negative 1. Negative 1 squared is positive 1. Plus 3 is 4. So that's another point, this 1, 4. And then if I plug in a 3 here, 3 minus 2 is 1. Squared is 1 plus 3. Well, that's also 4. So I've got 3 points here, and I know what a parabola looks like. I'm just going to go ahead and draw it in. And this is my function, f of x. Make it nice and dark with arrows. So that's the function. And we're supposed to label each function after graphing them. So I did. I labeled it f of x. Now to do the inverse, remember you just take each of these points and you flip the x and the y. So this 4, 1, sorry, this 1, 4 becomes 4, 1. So over 4 up 1. That 2, 3 becomes 3, 2 over 3 up 2. And that 3, 4 becomes 4, 3. So over 4 up 3. And then I can kind of graph this inverse and label it f negative 1 of x. That's the inverse. So you can see its reflection across this line y equals x. And there's a simple question here. Is the inverse a function? Does it pass the vertical line test? No. Right there, I'm touching 2 points. One right there, one right there. So this is not a function. The inverse is not a function. The domain and range of the function. Well, the domain is how far left to how far right. This thing's going to go left forever and right forever. So we're going to say the domain is negative infinity to positive infinity. The range is how low to how high. The lowest y is 1, 2, 3. And it actually touches 3, so I'm going to write that in a square bracket. And the highest y, well, it goes up forever. So that's infinity. And that should be a square, that should be a rounded parentheses right there. And the nice thing about inverses is that their domain and range they just flip them. So the domain over here is the range over here, and the range over here is the domain over there. So domain becomes 3 to infinity for the inverse, and it becomes negative infinity to positive infinity for the range. So the domain and range, they just flip. That's it. Well, let's talk about a couple of other things here. So there's two more problems like that you can do. I want to go to section 4 here, where it says find the inverse of each function. I just want to show you one. Let's try f here. I want to find the inverse of f. The first thing I do, and if you watched my last video, you know I've already done this on the other video, but this is just a reminder. The first thing you do is change f of x to a y equals. So just change the f of x to a y. And then flip the x and the y. So x equals the square root of 2y minus 3. Now we need to isolate the y, meaning get the y by itself. So the first thing to do is add 3 to both sides. And get x plus 3 equals the square root of 2y. And to get rid of this square root, we need to square both sides. So that's going to become x plus 3 squared equals 2y. Because that square cancels out that square root. Last thing to do is divide by 2 on both sides and get y equals x plus 3 squared, all divided by 2. Now this is almost it. This is almost the answer. The last thing we need to do is change that y into function notation. It's not an inverse until you tell me it's an inverse. And that's what this tells me. This f negative 1 of x. So this is the inverse. So x plus 3 squared, all divided by 2. So that's review from last class. Now what I wanted to spend a lot of time on is this side here. Use the composition of functions to determine if the functions are inverses of each other. So it's just asking you to find f of x or g of x. F of g of x or g of f of x. And I want to do a couple of these. And I think I'm going to start with number 8. I'm just going to arbitrarily choose number 8 here. And I'm supposed to answer the question, are these things inverses of each other? Well, I'm going to start by finding f of g of x. The way you do this, you might remember from last time, is you start with f of x, but everywhere you have an x, just put a set of parentheses. So this is f of x without the x. I just left a set of parentheses where the x was. And inside these parentheses, it's going to be the h. I'm sorry, I wrote g there. It's supposed to be an h. My mistake. F of h of x. So I'm going to put all of h up into that parentheses. Plus and minus the square root of x minus 9. And I just need to simplify this thing. Get as simplified as you possibly can. And what we're looking for is when it's all the way simplified, if it's just an x, then they are inverses. If it's anything but an x, like x plus 4, x squared minus 9, anything but an x, then they're not inverses. So when you square this thing, the positive stays positive, the negative turns positive. So this positive and negative goes away. And when you square a square root, those things go away. So all that you're left with in parentheses is x minus 9 plus 9. Because that squared took care of all that other stuff. It just canceled it right out. Well, we don't need those parentheses anymore. So we just got x minus 9 plus 9. And minus 9 and plus 9 cancel each other out. Which means all we have left is an x. And I told you that's what we're looking for. When all you have left is an x, the answer to the question, are they inverses? Yes. The two functions are inverses. That's the answer to the question. Don't forget to answer the question. Are they inverses? So I thought I'd do one more like that. So pick one that looks scary. Why don't we try number 2? And we'll give number 2 a shot. So it's the same process. Start with g of f of n or f of g of n. It doesn't really matter which one you pick. Let's just pick g of f of n. And so I'm going to write everything in g except for the n. And where there's an n, just write some parentheses. Negative 12 minus 2 parentheses, because that's where the n was, all over 3. Now, inside the parentheses, you're going to want to write the f. So this negative 5 plus 6n all over 5. And now it's a simplification. So we get to do some algebra. This negative 2 is going to distribute inside this parentheses here. So I've still got the negative 12, and I've still got over 3. But now, negative 2 times negative 5. Actually, I'm going to keep the minus and just distribute the 2. So 2 times negative 5 is negative 10, plus 2 times 6 is 12n, all over 5. Now I've got a nasty fraction up there, and I can reduce it a little bit. So let's do that. So I still got the negative 12, and negative 10 divided by 5 is going to be a negative 2, and positive 12 divided by 5, well, that's 12/5. There's not much we can do with that. We can make it a decimal, though. So 12 divided by 5, that's going to be 2.4, so plus 2.4n all over 3. All right, we're almost there. Now, negative 12, and distribute the minus sign now. Negative 12 plus 2 minus 2.4n all over 3. At this point, you could probably stop and ask yourself the question, all right, we've done a lot of algebra here, but does it simplify to just n? Is the n going to be by itself after I do all this algebra? And hopefully you can clearly see at this point that no, these things do not equal n. It's not going to simplify to n. So don't forget to answer the question. No, they are not inverses. That's the important stuff there. So we did a couple of things. We proved that functions are either inverses or not inverses based on the algebra. We showed how to find an inverse algebraically, and we also graphed inverses and identified their domain and range and determined whether or not they're an inverse, or sorry, if they're a function. And that's what we accomplished in class in those days. So thank you for watching.